Hello, dear listeners, and welcome to a new episode of our Letter to Vox podcast. Welcome back. Today we're doing a deep dive into a text that, well, it tried to spark a full-blown scientific revolution in philosophy over a century ago.
It really did. We're looking at Bertrand Russell's 1914 lectures, which became the book Our Knowledge of the External World as a Field for Scientific Method in Philosophy.
And the mission here is to really get under the hood of his argument. He wanted philosophy to stop being this speculative, poetic thing.
Exactly. He argued it needed to deliver piecemeal, detailed, and verifiable results, like a real science, like physics or math.
And the testing ground he chose for this new method was one of the oldest problems there is. It's this huge gap between what we actually experience with our senses, what he calls the crude data of sense.
Right, the immediate stuff, the colors, the shapes, the sounds.
And the very abstract, clean concepts that physics uses, space, time, matter.
Yeah.
How do you get from the wobbly, subjective experience of seeing a table to a physicist's unchangeable equation about its mass?
That gap is just enormous. And philosophers for centuries had basically thrown up their hands. They either said, well, the physical world of physics must be an illusion,
Or our senses are just lying to us.
Exactly. And Russell comes in and says, no, there's a third way. We can show how you can logically construct the world of physics out of the world of sense.
So before we get into the how, let's talk about the man himself, Bertrand Russell. He was a lecturer and fellow at Trinity College, Cambridge, a fellow of the Royal Society. A giant of early 20th century thought. And these lectures were given in Boston in 1914, right as the world was about to change forever.
And he wasn't working in a vacuum. His ideas were forged in this incredibly intense collaboration with Alfred North Whitehead.
On Principia Mathematica,
Yeah.
the book that tried to derive all of mathematics from pure logic.
That's the one. And that project is key because they weren't just, dabbling in philosophy. They were fundamentally reinventing mathematical logic itself. And Russell's big idea was that this new, powerful logic wasn't just for mathematicians.
It was the tool philosophy had been missing.
Yes. A tool that could finally produce results that were, and this is his phrase, independent of the tastes and temperament of the philosopher. Objective results.
Okay, so let's unpack that tool, this logical analytic method. What are we actually talking about?
At its core, it's about applying this new mathematical logic, what they sometimes called logistic to old philosophical problems. It's about analysis.
Breaking things down.
Breaking things down. You take a big, messy, familiar concept like matter or mind or even a point in space, and you analyze it down to its simplest, most basic parts, the things you can actually verify.
The hard data.
The hard data. And once you have those primitive building blocks, you then try to reconstruct the original concept using only logic.
And Russell believed this method could finally settle some of these ancient debates, like the one between realists and idealists.
That was the hope. He argued that those debates were stuck not because people weren't smart, but because their logical tools were, frankly, primitive. He points specifically to the problem of infinity. For centuries, anytime philosophers tried to talk about continuity or infinite sets, they just ran into contradictions. It seemed like a dead end.
Because if you can't logically handle infinity, then physics, with its infinitely divisible space and continuous motion, becomes a paradox.
It becomes a huge paradox, which is why the work of Georg Cantor, the mathematician, was so critical. Cantor developed a rigorous theory of infinite numbers, and Russell saw that this wasn't just a mathematical curiosity. It was the key that unlocked the door. It finally made a scientific philosophy possible.
Okay, so with the stage set, let's look at what Russell was pushing back against. He opens his book with a pretty brutal assessment of philosophy's history.
Oh, it's scathing. He says it's made greater claims and achieved fewer results than any other branch of learning. He saw it as a field that just wasn't making progress.
And he traces this failure way back, all the way back to the ancient Greeks.
He does. He talks about this classical tradition, which he says was still dominant in universities when he was young. And it was all built on this, what he calls a naive faith in the omnipotence of a priori reasoning.
Meaning reasoning from first principles without needing to look at the world.
Exactly. And you can see where they got that idea. Look at geometry. The Greeks discovered that you could start with a few simple axioms and just by using pure logic, deduce these incredible, complex, eternal truths about shapes.
And they thought, hey, we can do this for everything, for reality itself.
That's the hubris, right? The feeling that the human mind can just think its way to the truth of the universe. But when you apply that method to the messy empirical world, you get some very strange results.
You get philosophers proving that change is an illusion, or that all of reality is actually just one single thing.
Conclusions that fly in the face of, as Russell puts it, patent facts. And for the traditional philosopher, that wasn't a problem with the method, it was a problem with the facts. For Russell, as a scientifically minded thinker, if your logic leads to a conclusion that contradicts obvious experience,
Your logic is probably wrong.
your starting premises are probably wrong. Something's gone awry.
And he connects this way of thinking to a very specific, and he thinks psychologically motivated idea,
Yeah.
the block universe.
The block universe. Yeah, this is the idea that everything is fixed, orderly, and sort of predetermined. It's the legacy of that Greek logic combined with, a medieval desire for a tidy, God-ordained cosmos. Think of Dante's universe. Everything in its place.
It's comforting.
It's incredibly comforting. It gives you the illusion that you understand everything. But Russell says it's driven by a psychological need for safety, not a search for truth. It closes off possibility.
Whereas the new logic he's proposing is all about opening things up.
Absolutely. The new mathematical logic isn't about proving what must be true. It's about mapping out what could be true. It shows you the range of possibilities, and then it's up to science, to observation, to figure out which possibility is the actual one.
So that's the old tradition he's rejecting. But what about the new ideas of his own time, the early 20th century? He goes after this movement he calls evolutionism.
Yes, and he lumps in figures like Nietzsche, the pragmatists, and especially Henri Bergson. This was the hot new thing, and it presented itself as being very scientific.
Based on Darwin.
Right. But Russell saw it as a philosophy for the tender-minded. It was an escape hatch for people who didn't like the cold, mechanical view of the universe that physics seemed to present. It was a way to feel that life and progress and spirit were still central.
And to do that, you had to kind of sweep logic under the rug.
You had to, and Bergson's the prime example. For Bergson, reality, especially life, is this continuous flowing stream, an unbroken momentum.
The durée.
Exactly, and our intellect, our logic, he says, is built to chop that stream up, to create artificial divisions, static concepts, things. It's a practical tool for survival, but it fundamentally misrepresents the fluid nature of reality.
So to grasp reality, you need intuition, not intellect.
And you can see why this is a direct threat to Russell's entire project. If intellect is fundamentally misleading, then a philosophy based on logic is doomed from the start.
So how does he fight back?
With a brilliant two-pronged attack. First, he questions the whole philosophical relevance of evolution. He says, look, the story of the amoeba evolving into a human being, that's a very specific local event that happened on the surface of one small planet.
It's not a universal law of the cosmos.
Not at all. Philosophy, for Russell, has to be general. It has to be impartial. You can't derive some grand metaphysical truth about the entire universe from what happened in a bit of mud on Earth.
That's a powerful critique. And the second prong.
The second is about its scientific basis. He says these philosophies are usually just a hasty scientific generalization, projecting Earth's history onto everything, bolted onto an unscientific, unsupported dogma. Usually the dogma that the whole process is good, that it's all leading somewhere wonderful.
It's wishful thinking disguised as science.
It's philosophy built to give satisfaction to our mundane desires, which is the one thing he insists scientific philosophy must never, ever do.
But his killer blow, I think, is against Bergson's dismissal of the intellect.
Oh, it's a beautiful piece of logic. Bergson says the intellect is just a practical tool for survival, not for finding truth. And Russell just asks, okay, but how do we know about evolution? How do we know about the struggle for survival and our animal ancestry?
It's the intellect that figured all that out.
It's the intellect. So Bergson is using the results of the intellect to prove that the intellect is unreliable.
It's a self-refuting argument. You can't stand on a branch while you're sawing it off.
No, you can't. And Russell adds that this glorification of intuition is dangerous. Intuition is incredibly valuable. He says, we can be completely blind to our own faults, our own vanities, while our friends can see them perfectly clearly using objective observation. In the end, the slow, careful, logical method of the intellect is just more reliable.
So he clears the ground. He rejects the dead end of the classical tradition and the fuzzy thinking of the new evolutionism. He's making space for something new.
A philosophy built on the bedrock of logic and verifiable fact.
Okay, so if the essence of this new philosophy is logic, We need to understand what makes this new mathematical logic so special.
The absolute key difference, the thing that changes everything, is how it handles relations.
Relations.
Yes, traditional logic, going all the way back to Aristotle, was obsessed with the subject-predicate form, the idea that every sentence is ultimately about a single subject having a certain property. The ball is red. Socrates is mortal.
Right, subject, predicate.
And if you believe all propositions must fit that mold, then you have a huge problem with statements like A is greater than B.
Because that's not about A having a property or B having a property. It's about the connection between them.
Precisely. The traditional view had to try and reduce that relation to a property of A or a property of B, and it just doesn't work. It completely falls apart when you encounter what Russell calls asymmetrical relations.
Okay, what's an asymmetrical relation?
It's a relation where the order matters. If A is the father of B, then B is not the father of A. If event A happened before event B, then B did not happen before A.
The relationship only goes one way.
It's directional, and this is crucial. The world as we experience it, the world of space, of time, of series, is completely saturated with these asymmetrical relations. And traditional logic had no way to account for them. It was a massive blind spot.
So once you admit that relations are real, fundamental parts of logic, irreducible to simple properties,
Right.
what does that unlock?
It unlocks everything. Russell says that once you accept the reality of asymmetrical relations, all the old logical arguments for why the sensible world must be an illusion just evaporate.
Because those arguments were based on a faulty, incomplete logic that couldn't handle the very structure of our experience.
Exactly. It's logic itself that saves reality. It vindicates our common sense experience of a world structured by space and time.
That is a huge move. So with that foundation, he starts classifying the different kinds of facts that logic can work with. He starts small, with atomic facts.
Atomic facts are the simplest things you can say, the direct reports of your senses. This patch I see is red, or a simple relation you observe. This is to the left of that. They're the empirical bedrock.
Then you build up from there with connectives.
To get molecular propositions, these use words like if, or, and. For example, if it rains, I will take my umbrella. And the really interesting logical point here is that the truth of that whole if-then statement is a separate fact from whether it's actually raining or not.
The logical connection itself is a kind of fact.
A molecular fact, yes. And then the next level up is general propositions.
All or some.
All humans are mortal. Some swans are black. And this is where Russell launches his big attack on old-school empiricism.
The idea that all knowledge comes purely from the senses.
Right. Because he points out that you can never get to a general truth like all humans are mortal just by observing particular cases. You can see 1 million mortal humans, 1 billion. You still haven't logically proven that the next one you meet will also be mortal.
You're always making an inductive leap.
You are. And that leap, the principle of induction, the belief that the future will resemble the past, is something you have to assume. You can't prove it from experience because any attempt to prove it uses it. You'd be saying, well, induction has worked in the past, so it will work in the future, which is a circular argument.
So what's the implication?
The implication is massive. It means that if we know any general truths at all, and the truths of logic are general truths, then some of our knowledge must be non-empirical. It can't all come from the senses. We need this primitive logical framework to even start making sense of our experience.
So we have our tools, our logic is validated. Now the grand project, reconstructing the external world. Russell says the philosopher's job isn't to deny common sense, but to examine and purify it.
And to do that, you have to sort your data. He makes this brilliant distinction between hard data and soft data.
Okay, what's the difference?
Hard data is the stuff that resists doubt. No matter how much you reflect, you can't really doubt it. For Russell, this is 2 things. The immediate, particular facts of your senses. I am now seeing a patch of blue, and the general truths of logic. That's your foundation.
And soft data.
That's everything else. The beliefs that start to look a bit shaky under pressure. The biggest one is the belief that objects continue to exist when you're not perceiving them.
That my desk is still here when I leave the room.
That's a very strong belief, but it's an inference. It's not hard data. Another one is the belief that other people have minds. Again, a very reasonable inference from their behavior, but not a direct, certain fact of your own experience.
I want to zero in on his point about sense data, because he says something that sounds really counterintuitive at first. He says there are no illusions of sense.
It sounds strange, but it's a very precise point. For Russell, the sense datum itself, the patch of light, the sound, is always real. It's an event that is actually happening. If you have a dream, The visual images you experience in the dream are, as data, completely real.
The illusion isn't the data, it's the inference we draw from it.
Exactly. If you see a mirage in the desert, the shimmering pattern of light hitting your retina is a real physical event. That's hard data. The error, the illusion, is the inference. Therefore, there is water over there. He insists we have to treat the data of dreams and waking life with the same respect initially, because as data, they are equally real.
Okay, let's take the famous table example. I walk around a table. Common sense tells me I'm seeing one single, persistent object.
But if you stick to the hard data, what do you actually have? You have a continuous series of changing appearances. The shape changes as your perspective shifts, the light reflects differently, the color seems to alter. The idea that there's one single, unchanging, real table behind all those appearances is an assumption. It's soft data.
So how does he propose we handle this without falling into total skepticism?
He applies Occam's razor. Don't multiply entities beyond necessity. Why do we need to invent this unperceivable, metaphysical, real table? Maybe the thing just is the series of appearances.
So a thing isn't a substance, it's a specific, orderly collection of sense data.
A specific series of appearances connected by continuity and certain causal laws. That's it. This definition gives you all the predictive power you need for science and common sense, but it doesn't force you to believe in things you can never, ever experience.
This all has to be grounded in verification.
Absolutely. For any statement in physics to be verifiable, it must ultimately be translatable into a statement about actual or possible sense data. When a scientist predicts an eclipse, the theory is verified by the sense datum of seeing a shadow across the moon. It always comes back to experience.
To build this up, he uses what he calls the private world model.
It's a way to start the construction. He says, okay, let's imagine that each of us experiences our own private world, made up entirely of our own sense data. When you and I are in the same room, we're actually seeing two slightly different but very similar private worlds.
We say we're seeing the same table because my view of it correlates so closely with your view of it.
The correlation is so strong that we can map points in my visual field onto points in yours. This network of correlations between different private worlds is what starts to build up the public, objective world of physics.
So the thing is constructed from these correlated series of appearances.
Mm-hmm.
What about unperceived parts of the world?
This model handles that really elegantly. We can talk about ideal appearances, what the table would look like from a position where nobody is standing. These ideal appearances are calculated functions of the actual appearances that people are having. They're still tied to what is verifiable.
It's a way of filling in the gaps without inventing new metaphysics.
It keeps the whole structure grounded.
Okay, so we've constructed things. What about space and time themselves? We don't perceive mathematical points or instants.
We don't. We perceive extended patches and finite durations. So, just like with things, points and instants have to be logical constructions, not fundamental entities.
So how do you construct a dimensionless point from a world of extended shapes?
You use what he calls the enclosure relation. Imagine you have a set of nested Russian dolls or a series of circles drawn one inside the other, getting smaller and smaller. A point isn't one of those objects. A point is defined as the entire logical class of all those enclosing objects. It's a way of specifying a location with infinite precision by using a group of finite things.
It's a definition based on relationships, not on some unknowable tiny thing.
Precisely. And you do the exact same thing for an instant in time. We only experience events that last for a little while. So an instant is defined as a group of events that are all overlapping or simultaneous with each other. It's the maximal set of all events happening at once. Again, you're defining a precise moment using the relationship of simultaneity between finite events.
Don't forget to subscribe and leave a like if you enjoy this podcast.
This entire logical construction of the world depends on being able to handle continuity and infinity. And that brings us right back to the old Greek paradoxes.
Back to Zeno. Achilles and the tortoise.
Zeno was so brilliant because his paradoxes weren't just clever riddles. They pointed to a genuine, deep flaw in the way people understood infinity and continuity.
The Achilles paradox, just to refresh, is that for Achilles to catch the tortoise, he first has to get to where the tortoise started. In that time, the tortoise has moved ahead a little bit, so Achilles has to cover that new distance, and in that time, the tortoise moves again.
And so on, ad infinitum. Zeno argued that Achilles has to complete an infinite number of tasks to catch up, which seemed impossible. For centuries, this was seen as a devastating argument against the reality of motion.
It made the world of physics, which relies on continuity, seem logically incoherent.
It did. And this is why Georg Cantor's work on infinity was so revolutionary for philosophy. He provided the logical tools to finally solve Zeno's puzzle.
So what was Cantor's big insight?
He redefined what an infinite number is by identifying its unique properties. The main one is what he called reflexiveness. A collection is infinite if you can take a part of it, and that part has the same number of members as the whole.
That just sounds wrong to our everyday intuition. The whole is always bigger than the part.
For finite things, yes, but not for infinite things. Think about it. Take the set of all counting numbers, 1, 2, 3, 4, and so on. Now take a part of that set, just the even numbers, 2, 4, 6, 8. You can create a perfect one-to-one match between every number in the first set and every number in the second set. For every number n, there's an even number 2n. 1 maps to 2, 2 maps to 4, 3 maps to 6.
So there are just as many even numbers as there are total numbers, even though the evens are only a part of the total.
Exactly. That property, reflexiveness, which seemed like a contradiction, is actually the definition of an infinite set. Once you accept that, Zeno's paradox dissolves. Achilles performs an infinite number of tasks in a finite time, and that's not a logical contradiction anymore.
It just shows that the sum of an infinite series can be finite.
Precisely. Cantor's logic provided the missing piece. Another property he identified is that infinite numbers are non-inductive. You can't reach them by just counting up one by one from finite numbers. There's a hard break.
All of this leads to the most fundamental question. What even is a number? For this, Russell leans heavily on Gottlob Frege.
Frege wanted absolute logical rigor. He asked, what kind of thing is a number? It's not a physical object. It's not a thought in your head. He concluded it must be nonsensible and objective. It's part of the world of logic.
The number 3 isn't the collection of 3 apples. It's what the 3 apples have in common with 3 chairs and 3 ideas.
It's the abstract property of threeness. So how do you define that logically? Frege's insight was to use the concept of a 1-1 relation. 2 collections have the same number if and only if you can create a 1-to-1 mapping between every member of the first collection and every member of the second.
Like the husbands and wives example. If every husband has exactly 1 wife and every wife has exactly 1 husband, you know the number is the same without having to count.
The relation proves the equivalence. So the formal definition becomes the number of a given class is the class of all other classes that are similar to it that can be put into a 1-to-1 relation with it.
It's incredibly abstract, but it grounds the concept of number in pure logic.
It does. And even though Russell himself later found paradoxes with the idea of classes, he showed that you can get around that. You can treat classes as mere symbolic fictions.
How does that work?
You can translate any statement that seems to be about a class into a more complex statement that's only about individuals and their properties. You get the logical power without having to believe that these abstract classes are real entities floating around somewhere. It's another application of Occam's razor.
Okay, we've built the world from the ground up with logic. Let's apply this powerful lens to one last big topic, causality and free will.
The first thing the scientific method does here is to basically throw out the old philosophical idea of the cause.
The idea of one single event being the necessary and sufficient cause for another.
Right. That's a simplistic ideal. Russell says that word cause really only belongs to the early rough stages of a science. As a science matures and becomes mathematical, it stops talking about singular causes.
What does it talk about instead?
It talks about causal laws. It talks about constant relations. It finds mathematical formulas like differential equations in physics that describe how a system changes over time. Newton's law of gravity doesn't say the Earth causes the apple to fall in a simple sense. It describes a constant mathematical relationship between mass, distance, and acceleration.
So causality is just a very complex constant relation.
It is. But, of course, to believe in these laws, to believe they'll hold true in the future.
You're back to needing the principle of induction, which isn't empirical.
You're always back to it. Which just reinforces his point that some of our most fundamental scientific knowledge has to be non-empirical, logical, primitive truth.
So, with this new view of causality as a set of constant laws, how does that change the free will debate?
Well, it deals very effectively with arguments like Bergson's. Bergson said, because of memory, every moment of your life is unique. Reading a poem a second time is a different experience from the first. So he argued the same cause doesn't produce the same effect, which means determinism is false and we are free.
And Russell's response?
Russell says that's a complete misunderstanding of what a causal law is. Causal laws don't require perfect, identical repetition. They describe relations between kinds of events. The fact that my total mental state right now is unique doesn't mean my actions are uncaused. It just means the causal laws are relating a very complex kind of cause to a certain kind of effect.
So what about that feeling we have when we're making a choice, the feeling that we could have done otherwise?
Russell argues that this subjective feeling of freedom isn't really evidence against determinism. The desire for a totally uncaused will, he thinks, comes from a lack of analysis. He wants to redefine what kind of freedom is actually important.
So what is the important kind?
The important kind is freedom from external compulsion. Even if our actions are completely determined by our past, by our desires, by our character, the causal chain is still running through us. My desire for B was stronger than my desire for A, so my desire caused me to choose B.
The choice originated internally from my own will. I wasn't forced by someone else.
Exactly. And that, he argues, is the only form of free will that is actually important. The ability to act on your own desires without being coerced. And that kind of freedom is perfectly consistent with a world governed by causal laws. It takes the scary, fatalistic sting out of determinism.
So what Russell has given us, really, is a complete methodology for philosophy, a blueprint.
It's a three-step process. Step one,
Right.
Start with your data, the common, vague, complex knowledge of the world. Step two, analysis. Break it all down into its simplest, most precise, logical proposition.
In step 3.
Synthesis. You take those simple, precise truths and you rebuild your knowledge in deductive chains, from the most certain things to the less certain. It clarifies what you actually know and how well you know it.
And it requires this incredible intellectual discipline. You have to be willing to doubt the things that feel most familiar and comfortable.
And you have to be willing to imagine the unfamiliar. He argues that philosophy has to lose what he calls its human interest. It has to stop making big promises about the meaning of life or the fate of the universe. Just like astronomy became a science when it stopped being astrology.
It has to aim for certainty, like Galileo finding the law of falling bodies, even if the results are small and piecemeal.
And he says the truly hard part isn't the synthesis, the rebuilding. The hard part is the analysis. That final step of finding the truly simple, primitive, logical components of our ideas. Once you find the right building blocks, the structure often snaps into place with incredible power.
So what is his final vision for the future?
His final vision is that for philosophy to finally make real progress, it needs a new kind of thinker. It needs a school of people who have rigorous scientific training and deep philosophical interests, but who are completely unburdened by the traditions of the past.
A fusion of the two cultures. It's a powerful idea. Okay, before we wrap up, let's crystallize the main takeaways from this deep dive into Russell's project.
Absolutely. Takeaway 1, method over system. The most important thing is the logical analytic method. Use the power of modern mathematical logic to get verifiable, detailed results. Stop building grand, comforting systems.
Takeaway 2, logic saves reality. This is a huge one. Our common sense world of space and time is actually validated by logic once you accept the reality of asymmetrical relations. The flaw wasn't in our experience, it was in the old, inadequate logic.
Takeaway 3, construction from data. The physical world isn't something we just find. It's a logical construction built from the hard data of our senses. Things, points, instants, these are all defined as series or classes of sense data, which lets us avoid inventing unnecessary metaphysical substances. It's Occam's razor in action.
And finally, takeaway 4. Free will is consistent with determinism. The important kind of freedom acting from our own internal desires, free from external force, is totally compatible with the scientific view that our actions are part of a world governed by causal laws.
And to leave you with a final thought, building on all this, if Russell is right, if philosophical progress really depends on finding the right logical tools and the right primitive axioms, does that mean the next great leap in philosophy won't come from a philosopher at all? Could it come from a breakthrough in pure logic or theoretical computer science, revealing a new structure for thought that we can't even imagine yet?
It completely changes where we should be looking for answers. That's a fascinating place to end. Thank you for joining us for this deep dive. We'll see you next time.